Hello, my dear students. In this today's lecture, we will discuss about the neutrino hypothesis, and we will talk in detail about the discovery of a neutrino, and then we will discuss about the various properties of a neutrino. Since neutrino, it is known as the little neutron particle, so which is a massless as well as chargeless particle. So it is very difficult to detect, and we will talk in detail about its experimental discovery, so which lead to the Nobel Prize in Physics for the discovery of these neutrino particles. So let us start our lecture. So these neutrinos, so they are present in this universe in many ways. So there are solar neutrinos. So the idea of first time which came from this neutrino, so it was originated from the interaction of a proton with the proton in the sun. So that is the hydrogen. So it interact with another proton, so which lead to the formation of this deuterium plus positron, and along with that this neutrino. So it is being this neutrino is being emitted. So this neutrino particle, it is first time called as the little neutral one. So in the initial years of its discovery, it has been compared with this neutron particles since it was discovered before the discovery of neutrons, so which was discovered by Chadwick, so in the year 1932. So initially scientists, they are comparing this neutrino particle as a neutron. Later it was proved wrong, and neutron, it was discovered from this nucleus in the year 1932. So this neutrino, it is also considered as this neutral particle. So the name this neutrino, it has been given by Fermi, so which first time sees these particle in the cosmic rays, so which are coming from this solar wind. So there are, if you look, there are a large number of neutrinos which are present in our atmosphere. So almost 10 raised to power 14 neutrinos, they are passing from our human body per second. However, the probability of their interaction with the atoms in the human body is very small, such that not even one such single collision it takes place in the whole year. So the physical properties of these neutrinos, if you talk about, so they are very difficult to detect because they carry no charge. So if they carry no charge, so they cannot produce any type of ionization in the matter. So usual method of neutrino detection, so which we generally use for these charged particle, it cannot be applied for this detection. So uh, because they do not ionize any matter, so they do not transfer any energy or momentum to any other particle with any collision, so it is very difficult to detect. So the discovery of these neutrino, it has been happened in the year 1934 for the first time, and experimental discovery of these neutrino, it first happened in the year 1956. So it almost take 20 to 25 years to prove experimentally that these particles, they are really exist. So if we talk about the beta decay, so the simplest radioactive beta decay of a free neutron, so I will write here the reaction. So when this neutron it converted into proton, and along with that this electron, it is being emitted. So it has been found that the combined mass of this proton and electron, it is less as compared to neutron. So what does it mean? That the amount of this extra mass, according to this law of conservation of energy, so that is from the Einstein's famous equation of mc square. So the mass which is being converted, it should be transformed in the form of energy, and this energy, it is being carried mostly by these electron particle. So uh, if we compare about this energy conservation for this beta decay reaction, so energy, it is not conserved, because what they have seen, that according to this reaction, most of the energy which is being carried by this electron, which is very very light, so it should have some sort of a monoenergetic peak, which should be at the end of this spectrum. But they have what found experimentally is that this beta spectrum, it is something like a continuous spectrum. So the experimental results, they are showing the continuous spectrum, but according to these theoretical calculations, so majority of the energy, it is being carried, and it should have some sort of a single peak, which is at the end of this spectrum. So these experimental and the theoretical results, they are contradictory. So the energy conservation laws, which are not fulfilled by these equations. So if you carry out the expression or the derivation of this energy, so since this is the reactant and these are the products, and the energy of the proton, which is being of the order of p square into 2 mn dash, while the energy which is being carried by this electron, that is of the order of p square plus mec square. And after doing the calculations, it has been found that the value of this energy which is being carried by this proton, it is very very less as compared to the energy of these electrons. So the recoil energy of this daughter nucleus, it is negligible small relative to the energy of this electron. So uh, uh, as I have told you earlier, so most of the energy which is being carried by this electron, so hence a monoenergetic line spectrum for the electron, it should be expected. But experimental measurement of these beta particle, so they show these typical continuous spectrum, so which is varying for a range from which varies from 0.51 and goes up to the order of a 50 mega electron volt. So what does it mean? So it means that due to this continuous spectrum of this beta particle, it means that these electrons, they are some sort of sharing some energy with some other particle. So later if you talk about this equation and the conservation of angular momentum and charge, it is also being violated. So I will write this equation of this beta decay, so which was first given. And if you talk about the spin, since these neutron and proton, they are building blocks of these nucleus, they are having half integral spin. So electron, they are also fermion, so they are having a half integral spin. So according to the law of conservation of angular momentum, so the angular momentum, it should be conserved, that is for the reactants and for the products. So that is before the reaction and after the reaction, so it should be conserved. But it has been seen that here the spin, it is of the order of half integral spin, while the total spin after the reaction, that is of the product, it is of the order of integral spin. So this is a clear complete violation of angular momentum. So therefore this nuclear reaction, it is not considered as valid. So therefore in the year 1930, scientist Pauli, so that is from Switzerland, he has presented a bold idea that in this beta decay there is some another particle which is neutral, so it is also emitted along with this electron, and this neutral particle, it carries the missing energy, and which allows this conservation of angular momentum and conservation of energy. So he modified this equation, and he modified this equation that there is not only the electron which are coming from the nucleus, and along with that there is some sort of neutrino and antineutrinos, they are also coming, and these two particles, they are sharing the total energy so with respect to each other, and that's why, so this beta spectrum, it is considered as a continuous spectrum. And if the energy of this electron it is carrying less energy, then majority of the energy it is being carried by this neutrino particle, and if this neutrino particle it is carrying a less amount of energy, then majority of the energy it is being carried by these recoil electrons. So similarly, these particle neutrino and antineutrino, they exist in pairs like these electron and positron. So when this beta minus decay, so there is along with this electron antineutrino particle is emitted, and for this beta plus decay, so when this proton it is being converted into neutron, and along with that this positron is being emitted, and along with that this neutrino particle. And now you check the total spin for these particle, like for proton it is having half integral spin, so these neutron which is a fermion having half integral spin, so electron and this neutron, so everyone it is having a half integral spin, so that is before the reaction, and after the reaction the spin it remains half integral, so it is following the conservation of angular momentum and conservation of energy. So the name neutrino, it was given by scientist Enrico Fermi, so who explained his famous theory of Fermi theory of beta decay. So he modified these Pauli's expression, and he designed a theory which is very famous, and still is used for these expressions. So he used this term, that is a neutrino, for this neutral particle, and the Italian meaning of this neutrino is the little neutral one. So its Italian meaning is little neutral one. So little is because it is a massless particle, that is its mass it is very less as compared to the mass of these electron. So generally it is being considered as a massless and chargeless particle, because it do not carry any charge. So that's why it is the little neutral one. So let us talk about some properties of these neutrinos particle. So first property is the neutrino's charge. So it has no charge, that is it is a neutral like a neutron, hence it is a little neutron. The absence of this charge it implies that it should be difficult to detect neutrino in this laboratory, and if you try to find out the balance of this charge equation, so neutron it is being converted into proton, and along with that beta minus plus antineutrino is emitted. So the charge of this neutron, it is a zero charge, it is a neutral particle. So proton which is having a plus e charge, and beta minus particle which is having a minus of e charge, this antineutrino, so which is having zero charge. So total product charge it is zero. So the charge is conserved for this reaction. So neutrino it has no charge. So it is a chargeless particle. So second property is neutrino's spin. So each building block of our atom, that is electron, proton and neutron spin, it is they are fermion and they are having half integral spin. Generally spin is measured in terms of angular momentum of this photon spin. So the reference we use for this photon, so the spin of a photon, so which is considered as 1, and we calculate the spin with reference to this photon. So the electron, proton and neutron each having this half integral spin, therefore angular momentum it is conserved in this beta ray interaction. So you can see from this equation that the total spin it is being conserved, like this is 1 by 2. So this is 1 by 2, and this electron or positron they can have this up or down spin. Similarly this antineutrino and neutrino, so they can have this up and down spin. So the total spin it is on the both side it is conserved. So third is mass of neutrino. So third property is mass of neutrino. So one of the consequences of this Einstein theory of relativity is that any massless particle shall forever move with the speed of light. Therefore, if neutrino it is considered as a massless particle, then similar like photon it should always travel at a speed of light. So that is the velocity of light limit, which is 3 into 10 is to power 8 meter per second. So the beta decay of this nucleus with this Pauli neutrino hypothesis, so we can write this equation as Az of a nucleus, it is being converted into a plus a z plus minus 1. So z plus 1 for beta minus decay and z minus 1 for beta plus decay. So similarly this electron and positron it is being emitted, and along with that this antiparticle, antineutrino and neutrino. So if you do the energy balance for this beta decay, then the energy of the kinetic energy of this beta particle, which is equal to kinetic energy of this uh, electron plus kinetic energy of this neutrino, so with which they are moving, and mvc square, which is the rest mass energy of these neutron, and T is the energy of this recoil nucleus, that is the kinetic energy of our recoil nucleus. Since the daughter nucleus which is being formed, it is very heavier as compared to this beta particle, therefore the kinetic energy of this recoil nucleus it is considered as very small as compared to these electron and neutrinos. So being very small values, we generally neglect this equation. So this equation it becomes of the order of Te plus T nu plus m nu c square. So if we generally consider that the maximum energy it is being carried by these electron and neutrinos, they are carrying very small energy. So for this beta decay, so we will generally consider the value of this T nu is equal to 0. So what we left with is Te maximum plus MUC square. So this relation it can be used for estimating the rest mass energy of these neutrinos and antineutrinos. So therefore from this equation we can find out the mass of this neutrino. So this rest mass of this neutrino it is equal to the difference in beta decay energy, which is calculated from the mass of this parent nucleus and the daughter nucleus. And there are a number of papers which have been explained this rest mass energy of these neutrinos. So the first estimate of this neutrino mass it has been made by Hanna and Pontecorvo in the year 1949. So they had estimated this mass of a neutrino which is of the order of less than 1 keV. So once we find out the energy, from this energy we can use using this Einstein mass energy relation we can calculate or we can estimate the mass of these particle. So later in the year 1976 this result was more refined by these paper published in PRL, that is by the Trektikovs et al. So they are from Moscow and they derived experimentally the mass of these neutrinos which is of the order of 35 electron volt, and this comes equal to of the order of 7 into 10 is to power minus 5 times this mass of this electron. So from this you can estimate that this mass of this neutrino it is very less as compared to this mass of this electron. So that's why we generally consider these particle as a massless particle. So later on further developments of various measurement techniques for this beta spectrum it has been possible, and from that there are some calculations which are explaining some other neutrinos mass, and the paper which has been published in the year 1987. So they are estimating that the mass of this neutrino it is of the order of which lie between this 28 electron volt to 41 electron volt. So there are various type of these neutrinos. Generally there are three types of neutrinos, and these variation in masses that is dependent what type of neutrino particle you are talking about. So neutrino fourth property is the nature of neutrino. So these like neutron and proton, so these are fermions. So they are having a half integral spin. So they are considered as fermions. So next property is antiparticle of neutrino. So the direct theory of this electron it has predicted some amazing results. This theory explained that there must exist a particle identical in every respect. So like for electron there is a anti electron which is generally considered as positron. So the existence of this positron it was verified using this cloud chamber techniques which has detected these positrons from cosmic rays. So this antiparticle idea it has been extended to all other particle physics. So the corresponding for every particle there is an antiparticle. So subsequently, so if there is a proton, there is a antiproton, and for neutron there is antineutrons. So this was detected, so they were detected in the laboratory. So behind all these antimatter and matter physics, a fundamental properties of this particle and antiparticle system is that whenever a particle comes in contact with its antiparticle, so they spontaneously inhale it. So similarly, matter and antimatter, it cannot exist together so for any appreciate time. So thus when an electron it comes in contact with this positron, so they destroy each other and they combine make two photons. So therefore our part of this universe, it contain mostly metal and very little antimatter, but there are chances or it is possible that in some other part of the universe, so there is a little of antimatter and very large amount of matter, so that is there. So there are atoms which are entirely made up of antiproton, antineutron, and antielectron. So according to this theory, so there is an antineutrino, so as the antiparticle of a neutrino. So the for every matter there is an antimatter. Therefore, for every particle there is a antiparticle. So depending upon what type of matter we are talking about. So this is the theory of antiparticle and particle physics. So for every neutrino, so there is a antineutrino. So next property is lepton number. So the electrons and neutrinos, they are called the leptons. So what are leptons? That is the light particle of half integral spin. So if electron and neutrinos, they are labeled as plus one lepton number. So they are labeled as plus one lepton number for this electron and neutrino, and all other particles, so they are considered as zero lepton number. So this beta decay, this possesses show no lepton on right hand side, and it must exhibit no lepton on this right hand side and left hand side. So let us discuss this lepton number for this beta minus decay. So there is antineutrino. So lepton number for neutron, it is 0. For proton, it is 0. So they are not leptonic particles. So beta minus, so they are considered as plus 1. So similarly, if a neutrino, it is a plus 1 leptonic, while antineutrino, it is minus 1. So total lepton number, it is conserved for this beta decay particle. So next property is helicity of neutrino and antineutrino. So neutrino and antineutrino have the same properties such that they have zero mass, zero charge, and half integral spin. So we have to find some property which can distinguish these neutrino and antineutrino. So experiments result show that a neutrino exhibit a handedness similar to a screw. So what does it mean? It means that a neutrino has its spin always anti-parallel to its momentum. So like if I am writing here, try to draw. So suppose this is a particle, so which is moving in this direction, and its momentum is upward, and then its spin, it will be in the opposite direction. So this particle is considered as neutrino. And while for antineutrino, so for antineutrinos, so its a momentum and its a spin, so they are in the same direction. So for antineutrino, spin is parallel to its momentum, while for neutrino, its spin is anti parallel to its momentum. So therefore, a neutrino, it is a left-handed particle. So this neutrino, it is considered as left-handed particle. So this all the leptonic number, helicity, straightness. So this all you will discuss in the fourth semester in your particle physics subject. I will not go in detail, but just give you some brief idea about these helicity and this lepton number. So this antineutrino, it is considered as a right-handed particle. And the handedness of this neutrino and antineutrino, it is generally described with helicity. So this helicity, so which develop a relation of this momentum with spin. So that is P dot S, where P is the momentum and S is the spin of this particle, and the value of this helicity, so that is equal to -1 for neutrinos, and it is equal to +1 for antineutrinos. And this above value of this helicity, so it has been confirmed by experiments as well. So it is confirmed by experiments as well. So which also uh, confirmed and got some prize in the year 1986. I did not remember the exact date, but this discovery of this helicity, it was also a very famous discovery in this nuclear physics. So this fixed value of helicity of neutrinos and antineutrinos, it implies that these particles move with the velocity of light. So next property is types of neutrinos. So generally there are three types of neutrinos which exist, which are present in this universe. So first type is the cosmic ray particle. So there are muons which are very much present in number in and in this cosmic ray, and muon, since it is a radioactive particle and it is 200 times heavier than uh, electron. So muon, it has intrinsic spin of 1 by 2, and when it decays, so this minus mu, it decays into electron plus antineutrino and neutrino. So the lepton number, it is again conserved for this reaction. So this is +1, -1 and +1. So total leptonic number, it is 1. So there are two kinds of muon. So one is a positive muon and negative muon. So similarly they are antiparticle to each other. So these muons, they interact with the matter through its electric and magnetic properties. So this muon, they all have the properties which is identical to electrons. So these muons, so they are identical to electrons, but it's behave like a heavy electron. So they are considered as heavy electron because the mass of these muons, so it is 200 times the mass of electron. And these neutrinos which are coming out from this cosmic rays, so they are generally known as muon neutrinos. So the neutrinos which are coming from these muon interaction, so which is from the cosmic rays, they are generally known as muon neutrinos. So therefore, were two types of neutrinos which we have discussed. That is, one belong to electron family, so which is coming from this beta particle, and that is known as electron neutrino. So which is from the nuclear interaction, and another is from the cosmic rays, and that is known as muon neutrino. And the third type of neutrinos and antineutrinos, so they were discovered as tau neutrinos. So third type, it has been discovered very late, that is in the year 1975. So that is third type of neutrinos and antineutrinos, so, and they are generally known as tau neutrinos. So this tau particle, it has been observed that a neutral particle, it changes from one type of to another, and with this emission of these tau, so when this positive tau, it changes into pions, and along with that this antineutrino particle, it has been coming out, and this has been experimentally detected in the CERN laboratory using this Large Hadron Collider experiment in the year 2010. So this is experimentally discovered in the CERN laboratory in the year 2010. And the last properties of this neutrino, so that is photons and neutrinos. Now, if we compare this photons and neutrinos, so both they are massless, chargeless. So both are massless. Photon is also a massless particle. It is a chargeless particle and stable. And both these particles, they move with the velocity of light. Furthermore, a particle with zero mass, it cannot decay. But still further, these massless particles, they are very much considered as a wave-like particle. So in spite of these similarities, photon, it is fundamentally different because photon has a integral spin. So that is, photon has spin which is equal to 1, while these neutrinos, they are considered as half integral particle having 1 by 2 spin. And the second major difference is the photon, it does not possess neutrinos lepton number, and it represent as electromagnetic radiation. So since these neutrinos, so they are considered as leptonic particle and they are having lepton number, while photon, it is not a leptonic particle and do not have any leptonic number. So photon, we know that a charged particle in rapid vibration, it produces coupled electric and magnetic field which produce through space and which propagate with the velocity of light. So these are considered as photons. So these electric and magnetic field of this photon, it can act on all charged particle of this matter. Thus this photons, it can be easily detected in the matter, or it can be easily stopped in the matter. So you have discussed during these gamma ray interaction or this photon interaction that there are electric and magnetic dipole transition which exist. So therefore, in the presence of matter, photon can easily be created as well as it can easily be destroyed. But in the absence of matter, a photon once created will go on with the same velocity. So therefore, a photon it undergo some collision with the matter. So it undergo interact with the matter due to having electromagnetic radiation feature. So on the other hand, this neutrino it is not considered as electromagnetic radiation. So it is created only in the decay process. This neutrino it is created only the decay process. So when one particle it break down and it decay into, so which is much weaker than this electromagnetic interaction. So this particle they are produced due to these very weak interaction. So it is very weaker than these electromagnetic interaction. So therefore the creation and absorption of neutrino, so it takes place through this weak interaction. And as we have already discussed the emission of this beta particle or the Fermi theory, it is because of this weak interaction. So this due to this weak interaction, the probability of capture process of these neutrinos it is very small. So a neutrino it is once created, it moves through matter with velocity c, and it is completely unconcerned about everything else because it do not interact with the matter, it do not undergo any collision with the atom or molecule with the matter. So therefore the detection of this neutrino it is very difficult. So on the other hand, the strength of an interaction it is closely connected with the speed of interaction. So thus a nuclear interaction it needs 10 raised to power minus 23 seconds, and the electromagnetic interaction it needs 10 raised to power minus 21 second, and this weak interaction it needs 10 raised to power minus 9 seconds. So this neutron experience it only undergo a weak interaction. That's why it is very difficult to discuss detect. So therefore how then, if it is very difficult to detect, then how it is experimentally detected that there is any existence of such particle, whether it is existed in the universe or it is just a theoretical assumptions. But experimentally it has been detected in the year 1956, which leads to the Nobel Prize for these American physicists, so who undergo a very beautiful experiment and detected this particle. So let us talk about how this particle it is being detected. So the experimental discovery of these neutrinos, so it has been discovered by these two physicists, that is Rain and Cowan. So these two American physicists, so they proved that neutrino was a real particle and its existence was admitted, but which was considered undetectable. So finally it is detected. So this is the team you can see. So the project that is known as a poltergeist project. So this is Professor Rains, this is Professor Cowan, and this is the whole team, experimental team, so who participated in this experiment. So it was in the middle 1950s that this Cowan and Rains they set up this experiment to prove the existence of these neutrinos. So that was the time when the first nuclear reactor for this civilian war it was put forward into operation. So Cowan and Rains they have the idea to take advantage of this nuclear reactor which is producing intense flux of these neutrinos. So these flux of neutrinos which are being generated from this nuclear reactor, so which is very large in number, ranging from 1000 to 10,000 billion neutrinos, so which are emitting per second per square centimeter, so which is much intense than those radioactive sources. So they took the idea like the inverse beta decay. So if we look at this reaction, so when this proton it is being converted into neutron, and along with that this positron is emitted, and along with that this neutrino particle it is emitted. Now if I write this neutrino on the other way around, and if it is being absorbed by this proton, and it changes its identity, like this neutrino it changes into antineutrinos. So this positrons which are particles of antimatter quickly found electron. So you can see that in this beta decay of fission product in the reactors, so they generate neutrinos, so which are actually antineutrinos which are being generated, and a very fraction of these antineutrinos have the opportunity to interact with these protons through the so-called simple inverse beta day interaction. So when these antineutrinos which are generated through this nuclear reactor, so when they interact with these protons, and so there is a reaction, it get converted into neutron, and along with that these positrons which are being emitted. So these positrons they are generally considered as the antiparticle. So and there are a large number of free electrons which is present in the nuclear reactor. So these positrons they interact with these electrons, and which then inhalate, and there is a formation of two gamma photons. So these positron and electron they easily capture each other, and there is a formation of gamma radiation. And you can see that from these detector that there is a emission peak of these gamma photons which is of the order of zero point 0.5 mega electron of energy. But Cowan and Rain realized that this signature was not enough to prove that positron which is they have detected was due to this antineutrino interaction. So they looked more precisely for the presence of this neutrino, and they accomplish the positron to confirm the reaction. So what they do is, so this is the more clear picture of this theory. So these are the detectors they have designed outside the detector, and within this they have added these cadmium liquid, and this cadmium liquid now you can see, so they added cadmium chloride in the water tank of 200 liters, and which act as a target and act as a detector as well. So that is considered as generally scintillation detector, which is used for the detection of these neutral particle or gamma radiation. So cadmium it is a efficient neutron absorber. So the neutron particle which are being formed from this inverse beta decay, so they are being absorbed by these cadmium particle, and when they absorb this cadmium particle they show a peak that is a characteristics de-excitation gamma radiation. So for gamma detection, Rain and Cowan introduced in the water liquid some scintillation. So they detected two peaks. So one peak which is due to these two peaks which are due to these two photons which are being formed that when these proton and the electron they inhalate and they form two gamma radiation, and one peak that is due to this neutron which is being formed. So this neutron it interact with this cadmium which is present in this water tank, and this de-excite and they emit this gamma radiation. So they form these two separate gamma radiation peaks separately. So this gives the clear cut pictures that these two gamma radiation, they are due to the formation of this positron, and this positron, it is how it is formed. It is when this proton, it is capturing these antineutrino particles. So these antineutrino particles, they are coming from these flux of these reactor. So this discovery prove the existence of these neutrinos and antineutrino particle, and later on they got these Nobel Prize for this discovery. So further on, so there are many more experiment which has been done, and they further break down these particles into quarks and leptonic numbers. So I will not go into in much detail, so that will you will discuss in your particle physics concept. So okay dear students, so this is very important article, so I feel the need that I must discuss this in very much detail. So I will share all these notes in your WhatsApp group, and if you have any query or any doubt, you can ask me in the comment section, or we can discuss through Zoom meeting. So till then, goodbye, see you in the next lecture.